click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome back to the subject of Machine Design 1. We are right now learning the design part of bolted joints. In last two videos we have seen the design of bolted joints considering two different aspects, case number 1 and case number 2. In today's session we are going to look at the case number 3 and going to design a bolt full-fledged. So let us begin with it. You can see the problem statement on the screen. It says that select a suitable bolt for the given arrangement. Arrangement have been given and there we have to do the design part. Now if you see, as compared with the previous numerical, there is no material data given, there is no factor of safety mentioned. So we need to do it from the scratch. So everything that we are going to consider. So this is how your diagram is, where the arrangement of the given bolts is in this manner and force is in the same direction. And that's why they share the axis and the action of force also. The force amount is given, which is 40 kilonewton, and we have been given the locations of the bolts. The bottommost edge is this of the given plate and their eccentric distances are mentioned. The first one is 8 centimeter, the second one is 20 centimeter. Number of bolts they have given, see, when they don't mention, it's the parallel arrangement or it is the sequential arrangement, and for that here there will be 2 bolts and in this case there will be 2 bolts. So there are totally 4 bolts. So let us name them or let us number them. It is your bolt number 1, bolt number 2, bolt number 3 and bolt number 4, and that is how your bolt arrangement has been given. We also have been given this particular distance, which is called the eccentric distance of force. The line of action of force is different as compared to the line of action of bolts or the axis of bolts, and that's why this is the eccentric distance given. So let us take out the important material properties and the parameters. The first given thing which is very important as usual is the given load. Then comes the eccentric distance, which is small e. The small is given 0.4 meter. Which makes it 400 millimeter. Now we know that when the locations of bolts are given, the bottommost bolts and the topmost bolt, they are given or they are expressed in terms of lengths. So we can identify this particular distance as length 1, length 2 and this particular distance as length 3 and length 4, which are equal. And therefore length 1 is equal to length 2, which is 8 centimeter. Which makes it 80 millimeter. Similarly, length 3 and length 4, which have been given 20 centimeter, are basically 200 millimeter. So with that, let us start. Important thing that we have to mention is, we know that load is in the same direction as that of bolt axes, and bolt axes are actually parallel with each other. Now, why we have written down this statement? If you remember the case number 3, there we had learned this particular case where the directions are same, and due to this there are two types of failure loads that come into picture. The failure comes because of the direct tensile force and it is coming for the secondary tensile force. They'll say how it is possible. We know that the direct force is in the same direction and hence it will act perpendicular or normal to the area of cross section of bolts. That is the first case, and that's why they call it direct tensile force. The secondary thing is, or the secondary tensile force is because of the tilting action. If you can understand this particular thing which is your plate, when the force is applied, will have the intensity of tilting down, and due to this tilting the moment comes into picture. This moment actually acts on both this bolt location differently. For this particular thing it acts as a compressive one, and for this particular thing it acts as a tensile one, and hence the normal force or the normal stress comes into picture, and that's why the secondary tensile force we need to consider. Let us designate the first one using Ft1 and the secondary one as Ft2. We know the Ft1, which is the direct stress, is very simple to understand, which is the force divided by the total number of bolts. The force is 40 kilonewton, of course, and total number of bolts are 4, and that's why Ft1 comes out to be 10 kilonewton, which is very simple calculation. Whereas when we need to find out Ft2, this expression is this. We need to find out the force in bolt number 2 and force in bolt number 3, which is given by this expression, force into length 2 or force into length 3, where this force is nothing but the resultant force which is acting because of the tilting action. The expression is quite clear from here. So force is force per bolt per unit length. Force per bolt per unit length, and that is how we are going to substitute the values. The total force given 40, the eccentric distance given is 400 millimeter divided by length square, or the summation of length square. We have got 4 different lengths, so that is how we need to add them. No, we know that length 1 and length 2 are same, length 3 and length 4 are same, and that's why this is how the expression will be derived. Before we move ahead, let us finalize this calculation. It comes somewhere around 172.3 kilonewton. So that is what the equivalent force per bolt per unit length, of which we need to take the actual force, which is going to be either F2 or F3, which is basically Ft2. Let's solve it here. We know that the maximum length will be L3 in this case, which is 200 millimeter. So 200. So as we solve this answer, we will get the answer somewhere around 34.48 kilonewton. That is how we have found out both the values which are responsible for failure. The first one direct tensile stress, second one secondary. Direct value we have got 10, and the secondary value we have got this one. In our next video, we will look at how to design the bolt considering its safe material conditions. Thank you so much for watching this video. If you like this video, please subscribe to Ekeeda.